Hi everyone, welcome back to Coding with Bharat channel. So today let's go ahead and finish off whatever has been left off out of the bi-weekly contest, that is the first two problems. So I'll take up the second problem first, then go ahead and take the first problem, right? So before starting, if you have liked the video so far, just go ahead and like this video as well, subscribe to the channel, right? And yeah, at the end we'll like always going to discuss some salient things or common patterns we can extract out from the problems that we discussed today, right? So let's go ahead and start with our problem, the second problem first, which goes like this. Okay, so it says, let's say you are given a zero index array nums and an integer k. So two things, a nums and a k. You at the end, what do you want to do? You want to make XOR of all the elements of the array equal to k. So basically you want XOR of all these numbers to become equal to k. For that you need to do certain operations. What is that operation? So in a single operation you choose any one element out of the array and flip one bit of this number to some other bit. So as an example, let me go ahead and say that let's say our array contains some elements like 2, 1, 3, right? So if I talk about 2, what is the binary representation? 0, 1, 0. If I talk about 1, it's 0, 0, 1. If I talk about 3, it's 0, 1, 1. So right now the XOR of the array is 0. Now let's say I want the XOR of the array to be not 0 but 3, right? So let's think about what we can do in this particular scenario. So basically I want the XOR of the entire array to become 0, 1, 1. So one operation that I can do to make the last bit 1 is probably to pick the second element, that is this one, and change the last bit of it to 0. So as soon as I do that, this number becomes 0, right? And now if I look at the XOR, the XOR becomes 0, 0, 1, because if I actually look at the last bit, there are two zeros and one 1, so the XOR will be 1. If I look at the second bit 1, 0, 1, the XOR will be 0, and last bit 0, 0, 0, so XOR is 0. We need to do one more operation. Let's pick any number, let's say 2, and again change the second bit to 0. So basically changing this also to 0. So as soon as I make it 0, 0, 3, the XOR obviously becomes 3 as well. So basically this is what you need to do. You need to look at the array, make some of these operations. So what is an operation? Take any one number, take any one bit of that number and change it, so that the result becomes equal to XOR of the total number. Okay. Feels like a fairly simple question. Like if you have been doing bit manipulation for some time, you ideally should have been able to get through at this point. If you have seen this question for the first time, just pause and think what could be the solution. Otherwise, let's get started with the main idea. Okay. So first thing that I would say, whenever you are given these bit manipulation questions, one of the common pattern here is to consider each bit distinctly. Each bit distinctly. That is, do calculation for each of them differently, right? Why? Because these operations which are bitwise operation like AND or XOR, they do the operations over the bit. So although if you are even given an array, that numbers of the array are not so much important, but actually what is important is each bit of different numbers. So as an example, if you are given an array and let's say you want to make its bitwise and equal to 5. Now let's look at 3. So 0, 1, 1. Let's look at 2. 0, 1, 0. 4, 1, 0, 0. If I take the bitwise and this is 0, this is also 0, this is also 0. So to make it equal to 5, that is 1, 1, 0, I need to make some changes in the second bit. What is that change? Change this to 1. And into the first bit. And what is that change? Change these two to 1. So now whatever operation is given, whatever operation in the world is given to make this happen, you have to think in terms of individual bit. And that is what exactly we are going to do in this particular question as well. So Yeah. Next, let's talk specifically about the XOR and how it works. So let's take XOR. So let's say there are some numbers. Let's 10101. Then let's say 11010 Let's take this one. Okay. So I don't know what the actual numbers are. I have put their binary representation, right? So with XOR, what happens? If you look at the number of bits here, number of one set bits here, at any particular index or any particular location of bit, then if that number is even, if the count of set bits or one bits is even, that is 1 2, we have even here, right? So then when we take XOR, because property of XOR is 1 XOR 1 becomes 0, so any two set bits would cancel out. So if this count is even, then the bit there would be 0. But if the count is odd, like here, just single one, so there would be 1. Similarly, we can quickly calculate for remaining. So even, so 0, again even, again 0, and again even, again 0. So the resulting XOR would be 0 0 0 1 0. So simple idea with XOR, if for any particular bit, if we are talking about, if the number of ones there is even, then the result of XOR is 0. If it's odd, the result is 1, right? So now, if let's say we wanted to change this so that the XOR becomes, instead of 0 0 0 1 0, it becomes, let's say, 1 1 0 0 1, right? Something like this. So how many changes would we need to bring? So in this particular bit, right now it's 0 because the count is even. We need to change the count to odd. How many operations do we need to make that change? Any one. We can literally pick any one of these numbers and change it to 0. So now the number of ones will become odd and this will actually change to 1. Similarly here, the result is 0 and we want 1. So if we look at it, the count is how much? Even. We want the count to be 1, which is odd. So basically just make any one change again, like either change 1 to 0 or change 0 to 1. So you don't really care which change you make, but any of those change will change odd to even or even to odd. So finally we just need to know XOR of all the numbers, how many bits are different here, from the result that we wanted, right? How do we calculate that? How do we calculate the different bits? Again, if we take XOR of this result with k, what will end up happening? Wherever the bits are different, 0 1 different, 1 0 1 different, 1 same, 0 same, sorry, different again, 1 different again, 1. So we just need to take XOR of all the numbers, take XOR with k, and just count the number of set bits in it. And those many changes or those many operations you would actually need to do, right? So let's go ahead. Let's code this out as well quickly. So I'll go here. I'll go to my problem. So let's say int result equal to 0. For now, we'll go over the entire nums and take XOR. So result XOR equal to it. Then again take XOR with k and then simply return number of set bits. So there is a common function, at least in C++, pop count, which we can use. So yeah, if I've forgotten the probably syntax of it, I can probably search it. So let me just go ahead and do that. Pop count C++, as it says, returns the number of set bits in the number, right? So you simply need to do pop count, right? So yeah, let's just do that. Let's use pop count. So return pop count of result. Let's see if we are actually able to get there. Okay, it says no matching function to pop count. Okay, let me again search pop count C++ syntax. Okay, built-in pop count. is what we use. So let me just copy it and use it here. So this is the previous one. So built-in pop count, right? Let me just run it. So I get 2, which is the answer here, and we can try to submit it. Yeah, and we are able to get through. So simple idea, just take XOR of all the numbers, take XOR with K, and finally whatever is left, we need to count number of set bits in it, right? Cool. If I talk about the time and space complexity, I think we had been missing it out in the previous problems. It is just going to be O of n in terms of time, and space is O of 1 because we are not actually using any extra space. Cool. Going ahead, important points from this particular problem. 2, 1, take each bit individually, right? Whenever you have bit manipulation questions, you can think about taking each bit individually. Second, special property of XOR, it cancels out set bits. So whenever there are two numbers and you want to find how many bits are different in them, you just take XOR and count the number of set bits in it, right? So yeah, these are the two major important points from here. Let's go back to our first problem and quickly solve that as well. Okay. So this one was fairly simple. It was simply an implementation problem. It said that let's say we are given an array of some numbers. Now it says a prefix of this array is called sequential if every number in the array is one more than the previous. So for example, if I go back here, let's say if my array goes like this, 7, 8, 9, 10, and let's say 15 or 18, let's say 16, so on. So this part is sequential. Why? Because 8 is 7 plus 1, 9 is 8 plus 1, 10 is 9 plus 1, right? So sequential part. So what you need to do, you need to find, let's go back to the question. You need to find the longest prefix that is sequential, right? So longest prefix that is sequential, and whatever the sum of the numbers there is. So for example here 7, 8, 9, 7 plus 8 plus 9 plus I think we had 10 also, right? Yeah, 7 plus 8 plus 9 plus 10. So sum of this, you need to find the first number x greater than this number, this sum, which is not there in the array. So as an example here, longest sequence is 1, 2, 3. So sum of it is 3 plus 2, 4, 5 plus 1, 6. So like smallest number greater than or equal to 6, which is not there in the array. So 6 itself is not there in the array. So our answer is 6. Let's look at this case also. Sequential longest 3, 4, 5. Sum 5, 4, 9 plus 3, 12. So we look for numbers greater than or equal to 12. So 12 is there in the array. 13 is there in the array. 14 is also there in the array. 15 is not there in the array. So answer is 15. So first number more than the sum that is not there in the array. So very simple idea. What we could have done first, we would find the longest prefix like by just iterating, calculate the sum of it. Now that we have the sum, we quickly need to run another loop starting at sum. For every element, we'll check if it's there in the array or not. If it's there in the array or not. The first number we don't find in the array, we will return. To speed up this process, we can use a set and put all the elements in a set so that we can quickly check if an element is there in the array or not. So I'll directly go to the code because nothing much to do here. So I've initialized my sum as num0. So at least the 0th element would obviously be sequential. Then I'm running a loop from 1 till the size. If my current number is equal to previous plus 1, I'll just add it to the sum because it is now part of the sequence. Otherwise, I'll break from the array because we have broken the sequential prefix. So now that much, whatever is left of, is the prefix only, and we'll break from the loop, right? Okay. Now I've taken a set, put all the elements in my set. Now I'm running a while true loop. Although this is very scary to look at because it's like an infinite loop. But if you carefully look at it, we are just going to have at max n elements. So this will run at max n times, right? To find the new element. So we'll look for the sum, whatever the sum was, right? We'll try to look it inside the elements first. If it is not there, sorry, if it's there, so not equal to ends mean that we were able to find it in the set, then we do plus plus. We try to find the next one. Otherwise, if it's not there in the inside the set, that means this is the first number which is actually not there in the entire array, and we'll simply return the sum out of it. So very simple approach. Ideally it's n log n because I've used an ordered set, but I would have easily changed it to unordered set and it will be O of n. Cool. So nothing fancy like as a pattern to take from here. The only thing that you can probably take up is that unordered set and unordered maps can let you quickly find if an element is there in an array or not, right? Which I think if you have been doing for some time programming, you would already know it. Cool. So I think this wraps up all the four problems of our bi-weekly contest. We'll start the weekly contest now, starting with the third problem, I guess, moving on to second and first. And we'll discuss some approach about fourth. Fourth is slightly complicated than necessary. So, but I'll try to make a video out of it, right? Cool. So let's see you guys in the next one. And yeah, bye bye. Do subscribe to the channel if you liked the video.